Okay, so today we're going to talk about special right triangles and rationalizing the denominator. This is just a review, so if you already know how to do this, you don't have to watch the video. Or if you need to only watch rationalizing the denominator, you can just scroll forward a little bit. So first of all, let's talk about special right triangles. There are two types of special right triangles. You have 45-45-90 triangles and 30-60-90 triangles. Why are they so special? Well, first of all, if you know why they're special, that helps you kind of remember the little formulas for them. So by the converse of the isosceles triangle theorem, if two angles of a triangle are congruent, then the sides opposite them also have to be congruent. So why is a 45-45-90 triangle special? Because that means it's an isosceles right triangle. So if you have a 45-45-90 triangle, then the two legs of the right triangle are going to be congruent. So if we were trying to do the Pythagorean theorem on these two, then we know that they're congruent. So if this is x, then that's also x. If we do the Pythagorean theorem on that, x squared plus x squared equals c squared. So then you would get 2x squared equals c squared. Divide by your 2. Take the square root. Take the square root. C equals x radical 2, because we know the square root of x squared, but we don't know the square root of 2. So this is the formula that you learned in geometry. That your two legs of your right triangle are the same. And then the hypotenuse of a 45-45-90 is just x radical 2. Well, for most of what we're going to need, we're going to be using a hypotenuse of 1. So then we're going to have to figure out how to find those. But I'm going to leave that up to you. Okay, the second special right triangle is a 30-60-90 right triangle. And you're probably looking at this triangle going, that is not a right triangle. No, it is not. What it is, however, is an equilateral triangle. Well, what do we need? What do we know about the angles of an equilateral triangle? If a triangle is equilateral, it's also equiangular. The three angles of a triangle add up to 180. So if they all three have to be congruent, then they all have to be 60. So if I start off with a 60-60-60 triangle and I drop a perpendicular down the middle of it, what does that do? That cuts the triangle into two congruent triangles, which then by CP-CTC, ooh, we're going back here, those would have to be congruent, making them 30. So that's how we create a 30-60-90 triangle, by cutting an equilateral triangle in half. So let's think about this. If this is an equilateral triangle, these are all the same. So that's my hypotenuse there. Well, when I cut that in half, what does that do to this bottom? That means that this is now half of the original. So that means that this is 1/2 x. Then if I would do my Pythagorean theorem to find this side, so I would have 1/2 x squared plus b squared equals x squared. So 1/2 x squared would be 1/4 x squared. If I subtract that over to the other side to get b squared by itself, 1 whole x squared minus 1/4 x squared equals 3/4 x squared. When I take the square root of both sides, b equals radical 3 over 2, because we know the square root of 4, don't know the square root of 3, x. So those are those relationships that you learned in geometry. So let's go back to those again. In a 30-60-90 triangle, the shortest side, which is the side across from the 30-degree angle, has to be half of the hypotenuse. Why? Because we cut a 60, 60, 60 triangle in half to get this. So this is half of that, and then the third side is radical 3 over 2 times the hypotenuse. Let's go back to the 45, 45, 90 one more time. The two legs are the same, and the hypotenuse is the length of those legs times radical 2. Okay, so how does this help us and not make more work on us? Well, so here, if I have a 45, 45, 90 triangle, and I know one leg, without doing hardly any work at all, well, if it's 45, 45, 90, it's isosceles, so that's also 3, and if I know my little shortcut there, the hypotenuse is just 3 times radical 2. Here I have a 30, 60, 90. Again, how does that help us? Well, I know that the side across from the 30 is half of the hypotenuse, so that's 5. And I know that the side across from the 60, ooh, this is ugly, is 10 times radical 3 over 2. Well, what do you notice about that? That's 10 over 2, which is 5, right? So another way that I could do this quickly without having to go back to that is just take my short leg times radical 3. All right, let's do another one here. 30, 60, 90 triangle again. Which side was I given? I was given the short leg, so that's 7. So that means the hypotenuse is 14. And again, two ways of finding this side. I can either do radical 3 over 2 times the hypotenuse, but then that would be 14 radical 3 over 2, which reduces to 7 radical 3. The other way to do it, short leg times radical 3. All right, and here, there's no 45s in here, but if it's marked as isosceles, then these have to be 45. So that means this is a 45, 45, 90 triangle. Without doing any work, I can say that my two legs are 8. All right, review of rationalizing the denominator. This should be relatively easy for you after what we did earlier this year. If we want to get rid of the radical on the denominator, we want to turn this into a perfect square. So I multiply that by radical 3, but whatever I multiply in the denominator, have to multiply in the numerator. So that gives me 5 radical 3 over radical 9. But we know the square root of 9, that's 3. So we just get 5 radical 3 over 3. Can we reduce these? No. You can't reduce something from inside a radical to something outside a radical. So there we go. Same thing down here. Multiply by radical 2 over radical 2, because that'll give you radical 4, which is a perfect square. So I get 8 radical 2 over 2. Now in this case, can I reduce these? No, but I can reduce my 8 over 2. So that should just equal 4 radical 2. All right, so let's combine what we know. So we have a 45, 45, 90 triangle here. We know that the hypotenuse should be x radical 2, but there's no radical 2 there. Well, that means that that radical 2 is already inside of there. So if I want to get it out to find these two sides, I have to divide by radical 2. So this side is 7 divided by radical 2, but we're not allowed to leave our radicals in the denominator. So then we have to rationalize. So this ends up being 7 radical 2 over 2. Once I've got that one, then this one's a piece of cake because it's got to be the same thing. Okay? All right. This one, this is across from the 60. So that means this one should be my short side times radical 3. But there's no radical 3 there. That means the radical 3 is already inside of there. So if I want to get it out, I have to divide by radical 3. But again, I can't leave that radical in the denominator, so I rationalize my denominator, 12 radical 3 over 3, which again, I can reduce those. So that means my short leg is 4 radical 3. And once I know my short leg, finding my hypotenuse is easy because the hypotenuse is just double the short leg. So if I have 4 radical 3 times 2, blast from the past, how do we multiply radicals? Outside, outside, inside, inside. So the 2 is outside of a radical, so it gets multiplied by the 4. So that's 8 radical 3. All right, so we're going to use that tomorrow, so practice up and get ready for tomorrow.